Most RAG systems do not fail because the model is weak. They fail because retrieval is fake smart and grabs the wrong evidence.
Exactly. And the tool people reach for is a vector store, which sounds mysterious, but is actually very concrete once you strip away the buzzwords.
So let's make it concrete fast. What is a vector store really, if I am the engineer who has to ship search that does not embarrass me?
A vector store keeps numeric representations of your content, called embeddings, plus a way to find nearby embeddings quickly, and usually the document text, IDs, and metadata linked to them.
So it doesn't just store documents, it stores coordinates for meaning.
Right. Imagine every chunk of a support manual becomes a list of numbers that captures its semantic content. The vector store saves that list, the chunk ID, maybe the source file, section title, timestamp, and the original text or a pointer to it.
Here's the tension. A normal database already stores rows and columns. Why is that not enough?
Because normal database lookup is usually exact or filter-based. You ask for customer ID equals 42, or title contains a keyword. Vector retrieval asks a different question. What stored chunks are most similar in meaning to this query, even if the words do not match?
Give me a practical case where that difference matters, not in theory, in production.
Say a user asks, how do I revoke an employee's app access after termination? Your docs might say deprovision account credentials during offboarding. A keyword search can miss it because revoke, app access, and termination are not the exact terms in the doc. Embedding search can still surface the offboarding policy because the meanings are close.
That sounds like the win. Now give me the trap, because this is where teams overpromise.
The trap is thinking embeddings alone are retrieval. They are not. Once you turn text into vectors, you still need a retrieval index, because you cannot scan millions of vectors one by one on every query and stay fast.
Why not? A vector is just a list of numbers. Compare the query to every stored vector and sort them.
Done if your dataset is tiny. Painful if your corpus is large. Brute force similarity search gets expensive fast. A retrieval index organizes vectors so you can find likely nearest neighbors without checking everything. That is what makes semantic search responsive enough for real systems.
So, the index is the difference between a demo and an actual product.
Often, yes. Without it, latency climbs, costs rise, and your retrieval layer becomes the bottleneck. Then your carefully tuned prompts do not matter, because the right context never arrives on time.
Let's do another example. Say I am building RAG for internal engineering docs. What lives inside the vector store step by step?
You split documents into chunks, like design docs, runbooks, API references, and postmortems. For each chunk, you create an embedding. Then you store the embedding, the chunk text, a document ID, metadata like team, service, version, and permissions, and you add that embedding to the retrieval index.
Then, a developer asks, why does payment retry spike after deploys? And the system embeds that question too.
Yes, the query embedding is compared against the indexed chunk embeddings. The store returns the nearest matches, maybe filtered to the payments team and current version docs. Then your RAG pipeline uses those chunks as evidence.
That filter part matters, because semantic similarity without guardrails can pull the wrong neighborhood.
Exactly. Vector search is powerful, but metadata filtering keeps it grounded. Similar meaning is not enough if the chunk is stale, from the wrong customer, or from a different product tier. Retrieval quality is relevance plus constraints.
Here is another strategic edge. If my lookup is exact, users must speak my schema. If my lookup is vector-based, my system can meet users in their language.
That is the shift. Normal databases are great at precise facts and transactions. Vector stores are built for approximate semantic matching. In RAG, that means they help bridge the gap between messy human questions and the wording in your source material.
But approximate can also mean dangerous. If the nearest chunk is merely kind of related, you can feed the model confident nonsense.
That is why retrieval design is not optional plumbing. Chunking, embedding quality, indexing, metadata, and top case selection all shape what evidence gets seen. The winner is not the team with the fanciest model. It is the team whose retrieval returns the right text under real pressure.
One more concrete scenario. Customer support bot, huge knowledge base, thousands of articles, constant updates. What does the vector store buy you there?
It lets a user ask, "My invoice failed after I changed cards," and still retrieve articles about payment method updates, billing retries, and account verification, even if none of those pages use that exact sentence. And because the store tracks metadata, you can restrict results to the latest policy and the user's region.
So, the vector store is not magic memory. It is a semantic retrieval engine with structure, speed, and context attached.
Perfect summary. It stores embeddings and the content around them, uses an index to retrieve similar items fast, and complements normal databases instead of replacing them.
If you misunderstand that, you build RAG that looks intelligent in a demo and collapses in production.
And if you get it right, your system stops guessing what matters and starts finding it. In RAG, retrieval is not the sidekick. It is the power source.